Hello and welcome to this out-of-sequence some assembly required video. David Murray, aka the 8-bit guy, recently posted a video about audio digitizers in Commodore 64 and Apple II computers. Here is a snippet from that video. I'm sorry about the bad audio quality of this video. There's actually a good reason, and no, it's not copyright. I think this falls squarely within the fair use category, and from the little interaction I've had with David, I think he would think the same. Actually, I would like to point him out. Not many YouTubers with over 1 million subscribers take the time and effort to become as approachable as David has, and it's something that I'm sure is taking him a lot of effort, and it should be pointed out. With all of that said, he is wrong. This is an Apple IIe enhanced. Well, it's backside anyway. And what we can see here is the monitor port, the joystick port, and next to it are two ports with an image of a cassette tape, one with a pointing from the cassette tape to the port and the other from the port to the cassette tape. Yes, this is an audio digitizer. Now, I know what you're saying. You're saying, Shahar. Yes, my name is pronounced Shahar. Deal with it. Surely this is only useful for loading programs from tape. To which I say, audio is audio, right? Again, I hear you say, but how many bits does it sample? To which I say, okay, yeah, it only samples 1 bit, right? But then again, the Apple's output is also only 1 bit, so that's okay, right? Yeah, okay. The Apple sound system is pretty horrible, but it is still capable of producing this. Doesn't seem so crummy now, does it? So how do I do it? With a very small program I wrote myself. I can go over it now, but before I do, let's go over just a couple of points about the Apple audio hardware. First, there's address C030. That's the speaker toggle or speaker out port. Any read or write to that address will toggle the voltage given to the speaker from 5 volts to 0 volts or vice versa, depending on what it was before. So essentially, any read or write to that address will produce a click. The other address is C060. If you read it, you will get the current state of the tape input port. Well, 1 bit. It will show up as bit 7, that is the most significant bit of the byte. We start with a load A from C060. That loads the value from the tape in. Again, bit 7 gets the value, which means that the value loaded here will be negative if the tape reads a high value. Which means that the next instruction, branch minus, will jump if the value is, and so long as the value is high. Once the value turns low, we load A from C030, which is the speaker out, which means we toggle the speaker, and then immediately start the same loop, except we're doing branch plus instead of branch minus. So we will loop here until the value becomes plus, which means low, then toggle the speaker, then loop here until the value becomes high again, and toggle the speaker again. Last, we jump back to the beginning to do it all over again. So that's 18 bytes altogether. I should know. I had to type it in machine language from the monitor. You have to admit, for 1-bit audio, this is pretty good. When I was a kid, Apple actually had sampling programs where you could record into memory things from the tape board and then play them back. I didn't take the time to disassemble them, but I can sort of see how they work. The program you just witnessed is using a tight loop to sample the tape board. That provides higher quality, but of course it means the computer can't do anything else at the same time. If we time it, the tightest loop possible there, which means the highest frequency we can sample there, would take 23 cycles from start to start again. At 1 megahertz, that translates to around 43 kilohertz. 43 kilohertz is really a very high frequency rate. We can make do with a lot less. Speech needs around 8 kilohertz, even less, which means that we have free cycles in order to do other stuff, such as write to memory. We can use those extra cycles in order to create some form of memory representation of the data we sample and then play it back. If you would like to see such a code written, please state so in the comments below. I might be able to pull the time away from the channel's main project in order to do that. With that said, I need a bit of extra hardware in order to do that. I have a working Apple IIe and a probably working disk drive. I say probably because I do not have any 5.25-inch floppy disks. So if you have any spare floppy disks, as well as any other spare Apple II hardware or Commodore 64 hardware, I would really appreciate it if you direct it my way. You can leave a comment below and I will be happy to contact you with how to do that physically. So there you have it. While our digitizer isn't particularly good, it's no worse than the sound system we use in order to play it back. So, win, I guess. Next video we will be returning to our usual program of trying to implement an Apple II on an FPGA. So, thank you for watching.